Folks, how's it going? This is Mr. Moray coming to you with a due now for March 17th, 2020. Happy St. Patrick's Day. In this video, we're going to talk about a little recap on factoring. And factoring is the method that we learned for turning standard form. And that's what you see here, 3 quadratics in standard form into, remember, what we called intercept form. So last unit we got introduced to the forms, right? What they look like. And we started trying to graph them and investigate them, right? And in this unit, what we're doing, x minus p, x minus q. Sorry, that's an x. What we're doing now is we are actually solving equations that involve quadratics in any form. Okay, we're going to mostly focus on standard form, and sometimes we want to solve it. For example, when we want to find the x-intercepts, we want to find the x's that make y equal to 0, right? And on the graph, those are represented as a point where x is that value that makes it 0, also known as a 0 or a root, and y is 0 because that's the output. Okay, so the first method we're going to try, our lowest energy method, is to do factoring, or kind of what we think of as the box in reverse. Some of you were there for the Polydoku activity that I handed out after the test, and then we kind of talked about on Friday before we were dismissed. And so from there, you guys got some intuition about how the box could work backwards. What I want you to do here is, using any method you want, go ahead and try to factor these, taking them from standard form, which they're in now, to intercept form. If you missed the lesson from yesterday, from 316, I recommend you take a moment to go to we.willnot.fail, or check the email that I sent out, the blast email, for the link to your class's specific Google Doc, and look up the video from yesterday and take a crack at that if you haven't. But when you're ready, go ahead, pause the video, try to factor these 3 quadratics. Then when you're ready, unpause, and I'll show you how to solve it. All right, so here we go. I got x squared plus 11x plus 10, my first quadratic here. So as I alluded to, and kind of as I talked about in the video, and unfortunately I'm going to be pretty unique here. Not a lot of people like to take this strategy. I'm going to use the box in reverse. Okay, I encourage you to stand up to them and to use the box strategy, because this makes, to me, more sense, like from a conceptual standpoint. So what we got to do here is, and I think a student showed this us with the Polydoku on Friday. So we know that the biggest power of x, right? Our goal is to get x squared plus 11x plus 10 back into this box right here, right? We're working our way backwards. So I'm saying if the area is x squared plus 11x plus 10, what could the length and the width be, right? So for example, if the area was 35, these are just random numbers here, 7 and 5 could be the length and the width. So, right, what we learned in Polydoku, those of us who were there, we talked about, is that a similar idea applies to polynomials, like these quadratics made of 1, 2, 3 different terms. So what we need is, what we know that this is going to have to be x and this is going to have to be x, because that's the only way you get x squared. Now we know that this number up top and this number to the left are both going to not have any x in them. And we know that because the only way that you're going to get an answer, a product with no x in it, is generally if either the x's cancel out, which I don't really think we would have that happening in a quadratic, okay, or these things having no x in them at all, them just being numbers, okay? So we can assume that this here is going to be a number and this here is going to be a number in this case. So we have to ask ourselves, how could we make it 10? Well, we could do 2 and 5, or we could do 10 and 1. They could also be -2 and -5, since a negative times a negative is a positive, or -10 and -1 for the same reason. But because the numbers have to add up to a positive, I know they're both positives because only a positive plus a positive equals a positive. So now I've got a 2 here and a 5 here. Let's say I tried that. Well, I would get 5x and 2x, but those don't add up to 11x. So in this case, I need to use 1 and 10. You can put a plus and a plus if you want, and you can put a 1 there if you want, but it's not required. Okay, here the order of the 1 and the 10 doesn't matter. You could have had the 10 down here and the 1 up there, but that's only because the number in front of x is 1 in both cases. When we get into cases where a is more than 1, you just have to be aware that it's going to actually really matter, because one of them is going to be, for example, if this was 2x squared, one of these would have to be a 2 in front of the x. And so then when you put a number here, if I put a 10 here, that 10 would be getting multiplied by 2. But if I'd put a 1 here, the 1 would be getting multiplied by 2. So you'll see more when we look at those, but just be like cognizant of the fact that it sometimes does matter where you put your coefficients. So what we know is, we know that this x squared plus 11x plus 10 is equal to x plus 10 times x plus 1. These are equivalent to each other, because if I take x plus 10, as you can see here on the right, and I multiply it by x plus 1, what I get is the thing that I started with. So these have to be equal to each other. Just as I could represent 35, instead of writing it as 35, I could represent it as 7 times 5. But in this case with quadratics, why is that helpful? Well, remember, if you want to find the x-intercepts, you have to make it equal to 0, right? But it's hard to find it when you're in standard form. But in intercept form, we can see that because we're multiplying these numbers together, that is x plus 10 and x plus 1, if they multiply and become 0, we know that one of them has to be 0. So if x plus 10 is 0, x is -10, and if x plus 1 is 0, x is -1. Okay, see, so because if we plug in -10, the left becomes 0, so everything is 0 because you're multiplying by 0. And if x is -1, you get the same thing with the factor on the right. So our intercepts are -10, 0, and -1, 0. This was a tricky case because here I chose one where it was like 10 and 1. And I think I talked about in my other video, you don't see that happen often, but just be aware, like, it does happen. Okay, and the 10 and 1 is kind of like, as you might say, kind of like slept on, but don't forget about it because it's not obvious. It's like, and you wouldn't think about it, oh, like times 1, duh, but it's important, and so you just want to make sure you get that. Okay. All right, and the next one we're going to do a similar thing. I'm going to use a black box on this one. So I put my x squared up top, a -72 on bottom, and I notice that I have a -72, and I'm multiplying two numbers. So what my intuition needs to tell me is that one of them is a positive and one of them is a negative, because it's the only way to multiply two numbers and get a negative. One of them is going to be negative. It's a fact. We know that about multiplication, and that's what's really cool about these problems. So much of it just comes back to the really basic facts about multiplication that you learned in elementary school. That's what's like so amazing. Like, so much complex stuff comes down to something that's like basic things that you learn at a young age. So I have 2 and 36. That would make 72. I have 4. I know it goes in there. It goes into 7 one time, leaving a remainder of 3, and it goes into 32 8 times. It doesn't work for 5. It will work for 3 as well, because 7 plus 2 is 9. So it goes into 24, because I know there's 3 days is 24 hours. Right, sorry. 3 days is 72 hours. Each hour is 24 days. Now, if 2 and 3 go into it, 6 goes into it. And it goes in a total of 12 times. That's an interesting fact there. 7 won't go into it because we can see it gets to 70. 8 will go into it 9 times. And at this point, because I've got my 8 and my 9, I'm basically done. Here's a fun fact. Whenever you're searching for factors, numbers that go in, start with your number and take its square root. Okay. The square root of 72 is about, well, it's less than 9 because 9 is 81. And it's greater than 8 because 8 is 64. Let's say it's like, I don't know, 8.5. I don't know exactly. Once you get past 9, or once you really get past 8, if you haven't found a factor, you're unlikely to find a factor at that point. Like, you're basically done. Because if you could have found one, it would have matched with one of the smaller numbers. That kind of makes sense? Like, for example, when I get to 9, right, 9 already had matched up with 8. Right? So I don't need to say it again. All right, so what are my options? So I know this has to be an x and this has to be an x because that's how I get x squared. Now here what I'm going to do is I'm going to do negative, let's see, which ones would work? I'm trying to get to -1. So we do a -9 and a +8, and this is 8x, and this is -9x. So these become -x. So I get x plus 8 and x minus 9. Those are my factors. So these two are equivalent. So if I was going to make this equal to 0, what I would do is I would make this equal to 0 because they're equivalent. So the solutions to the one on the right are the solutions to the one on the left. But on the left, you can't really tell how you'd make that 0. Whereas on the right, you can really clearly tell how you'd make it 0. All right, because if x plus 8 equals 0, then x equals -8. And if x minus 9 equals 0, then x equals 9. I'm not going to do the tricks. Again, people sometimes say, do the opposite, do the opposite. Don't do that. Don't do that. Don't follow any of those rules. If you don't know how to do this, if you don't have a rule, set it equal to 0 and solve, right? Subtract 8 on both sides. Set it equal to 0 and solve, okay? Please don't listen to anyone who's trying to tell you to do those rules because I'm promising you we're going to get to a time when a is bigger than 1. Those rules are not going to work, right? If one of the factors, let's say one of the factors was 2x minus 1, and you say, oh, do the opposite, it's 1. Well, look, 1 doesn't make that equal to 0. If you plug in 1, you don't get 0 there. So don't do that rule. Do not, okay? It's not that tough to set them equal to 0 and solve. At most, it's a 2-step equation. At most, okay? These were 1 steps. Okay, so then we get our intercepts, -8, 0, and 9, 0. Okay, now for x squared minus 49, which you notice is a missing b, you would probably solve this. We're going to learn how to do this. So what we're going to learn to do eventually is just save ourselves the time, add 49 to both sides, get 49 equals x squared, and say, hey, what numbers could I times themselves equals 49? So x could be 7, because 7 times 7 is 49, or x could equal -7. If you do it as the box, you get your x squared here. So here's my x and here's my x. I need two numbers that multiply to -49, but add to 0 because there's 0 x's. So what numbers, when you add them, add to 0? Well, they have to be opposites, right? Because only opposites, 1 and -1, 2 and -2, 10 and -10. Only those numbers, when you add them, do you get 0. So in this case, they have to multiply to -49. So that's -7 and +7, because then when you add, they cancel out. Okay, so my final answer is x minus 7 times x plus 7. Okay, Now remember, you're only making it equal to 0 if I'm asking you to solve. If I ask you to factor, you box this, you're done. If I ask you to solve it and make it 0, that's where you put in the 7 and the -7. So you have to remember the difference between solving and factoring. If I don't say to solve, you shouldn't tell me what x is equal to. It's cool to know what they are, but again, make sure you're answering the questions that's being asked. All right, so I hope you found this video to be informational. I know it's a little bit longer than a traditional do now, but I thought I'd go into some of those fine key points about this one. So I appreciate you tuning in to watch. Please make sure you check out the rest of the activities today. Contact me if you need to, whether at rmore at, you could email me, you could do remind, course IH, okay? Or you could reach out. I'm hoping to have a Google Hangout session soon, all right? So stay positive, keep asking questions, keep it up, and remember, you can do it. All right, thanks much for watching. Feel free to subscribe so you can stay up to date with the videos. Have a wonderful day, and don't forget to love math.